we went over the formula for the midpoint a little bit in class, but basically the midpoint is if you have 2 points A and B, the midpoint is the very center of the segment such that it cuts it in half. So the formula is you're going to add up the x's and divide by 2, and then you're going to add up the y's and divide by 2. You need to know the formula for the test, so make sure you have this memorized. It's basically an average. You're averaging the x's and you're averaging the y's. And then make sure you always write your answer as an ordered pair. So I need to have parentheses, and I need to have a comma separating them. So let's try. Let's say B is at 2, 3, and A is at -4, -3. So to find the midpoint, I let this one be x1, y1. You don't really even need to label these. This is x2, this is y2. So I'm going to add up my x's. So -4 plus 2, and it doesn't even matter what order you go in. Divide it by 2, and then my second one is going to be -3 plus 3 divided by 2. So now I'm going to simplify. -4 plus 2 is -2. Still have the divide by 2 over here. -3 plus 3 is 0 over 2. So now I simplify even more and have -2 divided by 2 is -1. 0 divided by 2 is 0. So my midpoint would be -1, 0. Which this is a pretty inaccurate graph, just a quick sketch. But you can see how -1, 0 is very close to the middle, if I would have drew it in right. Okay, let's do another example of the midpoint. So let's say that A is at -4, 6, and B is at 7, 8. And you're trying to find the midpoint M of the segment AB. So we don't need to graph it. So I'm going to write my x1, y1, and my x2, y2. And the midpoint is add up the x's, so -4 plus 7, and divide it by 2. And then add up the y's, 6 plus 8, and divide it by 2. And now I'm going to simplify. So this is going to be 3 over 2. So I have 3 over 2. And then 6 plus 8 is 14. And now I'm going to simplify this even further. So this is 3 halves is 1.5, and 14 divided by 2 is 7. So again, make sure you write it as an ordered pair. The distance formula is the actual length, so it's a length between 2 points. So it's always going to be a positive number. So again, you have your x1, your y1. It doesn't matter which order you go in. And then your x2 and your y2. And you need to have this formula memorized for the test. So what you're doing here is you're subtracting the x's and squaring them, and subtracting the y's and squaring them. And it really doesn't even matter what order you go in. So I'm going to plug this in. Just the square root of x2, which is -2, minus x1, which is 2, squared. Then a plus y2, which is -2, and then a minus 2, squared. -2 minus 2 is -4. Keep that in parentheses, squared. Plus -2 minus 2 is -4, squared. And I still have all underneath the square root. So now I have the square root of 16 plus 16, which is the square root of 32. So now, just like in algebra, we want to do a factor tree of 32. 32 breaks down into 2 and 16, 2 and 8, 2 and 2, and 2 and 2. So all of the prime numbers, I'm going to circle. So I have the square root, 32 is equal to the square root of 2 times 2 times 2 times 2 times 2. So because it's a square root, I can pull out one group of 2, another group of 2, and now I have 2 left. So the answer is 4 root 2. So if you can simplify and pull out doubles, that's what you need to do. Okay, in the last example, if we're trying to find AB means we're trying to find the distance between A and B. So I'm going to label it x1, y1, x2, y2. So its distance equals the square root of x2, which is 7, minus x1, which is a negative 5, squared, plus y2, which is 3, minus y1, which is negative 6, squared. And now I need to simplify it. So distance equals the square root of 7 plus 5, so this is 12 squared, plus 3 plus 6, which is 9 squared. So distance equals the square root of 144 plus 81. You'll never get a negative number because you're always squaring these numbers, so it's always going to be a positive number underneath the square root. So 144 plus 81 is 225. So distance equals the square root of 225, which is 15. Square root of 225 is 15.